Hi, this is Marat Karudinov. In this video I will show how to create initial and boundary conditions for global run. Before this video you should watch the video on creation of invariant datasets because you need invariant datasets created first. So in this video we're gonna use the grid that we created for a global case with about 10-kilometer grid spacing to simulate Hurricane Irma back in 2017, starting on September 5th and running it for about 7 days. So this video is for those who don't have access to NCAR supercomputer, because at NCAR they have massive amount of datasets, including ERA5. It's very easy to create datasets using NCAR computer. But if you don't have an account at NCAR, this video is for you. So you can actually find all the data online, and I'm gonna show how to find the data, download, and how to create datasets. Okay, so we start from online, looking for Copernicus website. So Copernicus ERA5. Okay, so now we go to this ERA5 hourly data on single level, and we click download data. Okay, so here first we will download sea surface temperature and ice cover, because those are time evolving data sets. They, unlike initial conditions like soil or initial state of atmosphere, here we need to update sea surface temperature and ice cover. So here you select reanalysis, then select skin temperature. It's the same thing as the SST of the ocean, so it doesn't matter. And also when you go to other data sets, you will find sea ice cover. So those two things needs to be checked. Now we need to select the year. It's 2017, and then month, it's September, and dates. Date range from 5th all the way to September 12th. And also we won't update SSTs too often, not every hour. We will update SST like say every 6 hours. So just check those. And then you select the whole available region, which is global. And then you select netcdf format for output. And then you just submit format. I won't do it because I already done that before. So I have basically, this is my requests. So it will go to requests, and it will take some time to actually get some data. So here, for example, we have, I don't know why I don't have bar here. So we have, my requests were fulfilled, all 4 of them. So now, right now we did only first one, which is this data set, hourly data on single level. So it took about, you see here, it's about like 10 minutes to fulfill my request, and the dataset is relatively small. So after that you just click download, and it will download it to your desktop, and then you need to rename it, because the name of it is like some gibberish. It's some very nonsensical name, so you give it some better name. So now next we're gonna download other two-dimensional surface data as initial conditions in this case, because we need soil, initialize soil levels, and we need to initialize snow cover. So those two things, two-dimensional data sets. For that we go to I already so you basically go back to your request form, like it would look like this. So you click oh, this one is the old one, sorry. Yeah, but yeah, it will show old one. So now we will choose something else, so we don't download skin temperature. We go to soil and snow. So for snow we're gonna download snow depth and temperature of snow, and for soil we basically click all soil temperatures and water, soil water tabs. We don't need soil type because model uses its own way of computing soil type, and we don't need sea ice cover here anymore. So basically that's it, that's all we need. And then we also make sure that we have 2017 September, but this time it's initial condition, so we don't need all these other days. We only need September 5th. This is when we start, and also we start at 0, 0, but 0z, so we need only one time point, and we need whole domain, netcdf, and then you just submit form. Forgot to mention that in order to get your data, first you need to register on this website. If you don't have your account on this Copernicus website, you need to register. So I already registered and logged in. It's very easy to do. Okay, so after that, what you need to do, you go, for example, to search. While your request, you don't have to babysit those requests, they will be there. To check on them, you just click your request, and then it will show the status of your request. So go to search. Let's say now we need three-dimensional data to initialize to our atmosphere. So you just type ERA5 pressure. It's pressure levels data, hourly. So you get hourly data on pressure levels. That's what you need. Download data. Okay, so you click download data. This one. Now you you click reanalysis, and then you choose the following fields: geopotential. These are three-dimensional, so they could be large. Specific, so cloud water, humidity, U and V components of wind, vertical velocity, cloud to liquid water, rainwater, and of course temperature. So that's all you need. And then you specify that you download all pressure levels, data on all levels. So you just basically toggle them all or select them all. And then you need 2017 again, September, and it's only one day, starting on September 5th at 0z. And you choose the whole available region, netcdf, make sure that it's netcdf format, output, and then just submit form. So okay, so now we're done with 3D data for initial data. So the only thing which is left is ozone. It's 3D data, but I usually use monthly ozone. I don't use this hourly or daily or whatever it is, because it doesn't really monthly. It's pretty plenty. It's enough for enough accuracy. Actually, you don't need actually to update your ozone like every hour or so. So for that we go to again. In this time we go to search, and we type here ERA5 monthly pressure, so pressure level data monthly. Now you see it's monthly average data on pressure levels. Okay, download. So now we have monthly average reanalysis, and then we select geopotential, that's what we need, and ozone mass mixing ratio on all levels, pressure levels. And then we specify the date, 2017, September, at 0, it's always just one-time sample for monthly data, and whole available region, net CDF, and submit form. So after you do that, this is what you would get. You would get 4, eventually they're going to be green tabs that you need to push, and you download them and rename them somehow, and then you transfer these files to your production computer, because you cannot run really global GSM on your desktop unless it's a really coarse resolution. So in our case it's 10 kilometer grid spacing, so of course you need some supercomputer for that. So you transfer this data to your supercomputer. Of course your supercomputer may have ERA5 data, but in that case it may be different and my scripts may not work there. So that's why kind of you could use this way, because it's guaranteed to work. Okay, so after you transferred it to your supercomputer, let's say that this is your supercomputer, and there is your model there. So you go to global data. Here you have some scripts that we will use. In the previous video about invariant dataset, we already covered how to create symbolic links. So it's symbolic links to data and BND. This is binary output, where it points to directory where binary output will be written. So this directory could be on some disk with large storage capacity, so that you don't have to store it, let's say, in the home directory here. And also you have NCD, where netcdf files will be stored. You already created those when you created invariant datasets. One more directory you need to create. It's ERA5 symbolic link that would point to actual directory where ERA5 data, or those files that you downloaded from Copernicus, will be stored. So, like for example, in my case, this symbolic link ERA5, you see it points to this directory somewhere. So that's what you need, and after that, after you've done that, and let's see what I'm in my ERA5 directory. So ERA5, and let's look only 2017 data. So you see, this is those 4 files that I downloaded using Copernicus website, and I renamed them like the following. So you see, it's soil, snow, dataset. This is initial condition for soil and snow. This is initial conditions for atmosphere on pressure coordinates, and this is evolution data set from September 5 to September 12 for sea surface temperature and sea ice. It's 6 hourly. So you see, always give name to file that actually tells you what in those files. And then ozone file, which is September, average September 2017. Okay, great. So now we have the scripts. Let's first start from soil. So we have this script init soil ERA5 not NCAR. So this script will work to work with your data sets that you downloaded from Copernicus, not from NCAR, not NCAR data sets, because they are slightly different in names and so on. Okay, so we'll create one, open one. Oops, sorry. Forgot to copy it. Okay. So here, what you need to specify is basically two or three things. you need to specify your grid that you created, the same grid that you used when you were creating your invariant datasets. In our case, it's 3840 by 1920 grid, like this. So it's the same name that you used before in our previous video. And then you specify date when you start your simulation. In this case, for IRMA, you specify 2017 year, then month 9, then day 05, and 00 at 0 hour. So then you specify that you want some copy of this data set outputted, of this interpolated data set outputted to netcdf directory, which is your NCD. Just you could take a look at what's actually in your binary files, because binary files difficult to see, but netcdf files you can check using your netcdf viewer that you use. So those are just standard directories, symbolic links that we specified. And then you specify the name of your ERA5 data file. So in this case, it's ERA5 soil snow September 5, 2017. Okay, and after that, you just execute this NCL script. I'm not going to do it because I've already done that before, and it just takes time. So after it's not going to take long, maybe a minute or so, you'll create your data. So next, what we're gonna do is create a snow data set. So again, we choose the one which you need snow, the one that says not NCAR. So we use that one. And here again, you specify your grid, 3840, and then your date when you start. So this one is for snow. It will initialize snow temperature and depth around the world where snow is, so you specify this date, the one that we want, and then you specify the file name. It's the same name we use for soil. It's just has a variable that's snow in it. Okay, and that's basically it. If you want a netcdf output, you specify here true. And then we just execute this script. So after it's finished, now we need to specify sea surface temperature and sea ice. For that we use the script evolve SST CI not NCAR again. So we choose one. So here we again specify our grid, 3840 by 1920. Specify our case, dates. In this case, it's 2 dates because this SST dataset evolving this time, as well as sea ice dataset evolving this time. So that's why we need 2 dates. One is when we start our run, and then date when we end, 9/12, 12th of September. So just make sure that other data sets here, not so this semicolon means comment in NCL. So it's basically commented a line out. Now we need sea ice here, true, because for some data sets so this script can actually not, if you don't need sea ice, it will not do it. For example, for regional runs, use the same script. So netcdf out true, and then you specify this your ERA5 data set that you created in Copernicus, and then skip as, so you will use, it's 6 hourly data, so you use each and every time point. So and skip equal to 1, it's already 6 hourly. But for ice, there is no need actually to make it 6 hourly. So I usually use 24-hour update. So it's and skip equal to 4. Okay, so everything is set, and then you just execute this script. Now it's time to create 3-dimensional data sets. For that, you use make 3D init, not NCAR. This one will create initial conditions for atmosphere. So it's the same deal, but here all three-dimensional data are actually on ERA5 grid, so it doesn't care about your grid that you use in your run. Model itself will interpolate to its grid from that data set. So here that's why you don't specify grid, so you specify only date, which is Irma 2017, 5th of September 5th. Then you specify identifier. So just your initial data set would be identifiable as one that used for global, because it doesn't have actually any grid information anymore, only ERA5 grid. So it's just all file names will have this global name in it. So just make it global, and netcdf out if you want a copy of it, set it to true. And then just specify the name of your ERA5 dataset on pressure coordinates. And that's it. And then you execute it, and it will very quickly produce the three-dimensional initial dataset. We will check them later. And now you need ozone, which is left is ozone for this case. You don't need any nudging data in this case. Choose make 3D ozone. It's the same thing as before, but it will be on netcdf. But the difference is that actually here you specify slightly differently. It's monthly dataset, so you specify year, start and end, because this data will change in time. Ozone changes with time. For example, if you have very long run, you can specify several monthly events data and even different years. So here's 2017, and then we downloaded only one month, September. So we start in that file just months starting at 1 and ending at 1. And then we specify the root, not the name of the file. The name is actually sep_2017.nc, but because year can be different, you specify only part of the file name, like this. And then you put global identifier, like global. If you have, for example, all months in the file, then you specify like normal, like from, say, if you want September, you need to specify actually 1 month before and 1 month after your period. If you, like, for example, running only in September, you need to specify August and November, October, because for interpolation in time you need actually, if it's monthly data, you need like months before and months after, right? So that's the only thing that. But here, because we use only one time, we want the model will not interpolate anything, so we have only 1 and 1 here. So let's look at our data. So we will use in our BND directory. So we use identifier of grid size, which is invariant datasets, because invariant datasets don't have any year information or anything like that. And then we'll take a look at global and 2017 global. So 2017 and global. Okay. So we have, you see, ice mask data in this range. We have initial atmosphere global initialization data set. This one is leaf area index. So this one is a land mask, land type, ozone data, snow depth, snow temperature with T in the name. And then soil, which is soil composition, like clay, sand, and then initial profiles of snow for this date. So it's initialization of snow, of soil content, of moisture content and temperature, and sea surface temperature dataset, and terrain. So we have everything that we need. So in another video we will actually go through how to set name list and run the model, and then we will take a look at the results. So thanks for watching, and happy computing.